Second application of dimensional analysis is deducing relations among physical quantities. Deducing relations of physical quantities. Okay. So now we are deducing equations for physical quantities. So what does this mean? This means that we can actually find the expression, like we have no expressions like potential energy equal to mgh or kinetic energy equal to half mv square or other kinematic equation like s equal to ut plus half at square. So all of these equations we derived using some method, right? One of such methods is this through dimensional analysis. So if we know the dependence of a physical quantity on the other fundamental quantities, we can consider as a product type of dependence and then find the relation. I'll tell you what I mean. I'll write a question. Such type of questions come for exam, and using this question I'll tell you how to actually deduce the relation. So I'll read the question. The question goes: consider a simple pendulum having a bob attached to a string that oscillates under the action of the force of gravity on the planet. Suppose the period of oscillation of the simple pendulum depends on the length of the string, mass of the bob, and the acceleration due to gravity on that planet. Derive the expression for its time period using the method of dimensions. So such questions will come. I'll tell you. So what is given? We have to find the time period of this pendulum. Okay. We know what a pendulum is. Pendulum is suspended from a steady surface and it will oscillate from to and fro, right? One to and fro motion is called one oscillation. So time period is the time taken to complete one oscillation. So to find that, we are given time period capital T is dependent on, we write directly proportional to in mathematical form, is directly proportional to such the quantity's length of the string. So we write L, length of the string, mass of the bob m, times acceleration due to gravity, lowercase g. So we don't know how much extent that these variables are helping this time, right? So like to what degree, like if is length more important or g is more important or mass of bob is the least dependent, we don't know such variables. So we just write the powers as a, b, c. We have to find these powers, then we can find the actual relation, right? So we gave the powers a, b, c. We have to find the a, b, c. Before that we have to make this equal to. So for making proportionality sign, we just equal to and multiply a proportionality constant k, L, A, M, B, G, C. This is our first equation. We'll come back to this equation. Now we write the equation in terms of dimensions. We write a dimensional equation. Time period is time itself with no other dimensions. K is a dimensionless constant, we don't write that. Length is L raised to A. Mass is M raised to B. G is acceleration, which is L t raised to minus 2 raised to C, right? If we solve this, we get L A plus C, right? L raised to A is here times L raised to C. So L raised to A plus C, M raised to B, T raised to minus 2C. So T raised to 1 is here. We don't have M and L, so we can assume they are 0 dimensions, right? So we assume those are 0 dimensions. So we have a dimensional equation here. Now we can equate it. If we look at it properly, we have L here, L here. The exponents are a bit different. So if we equate the exponents, we can write A plus C is equal to 0, right? And if we equate M and M, we have B equal to 0. This is our equation A. B equal to 0 would be our equation B. And if we equate these two, minus 2C equal to 1, this is our equation C, right? Now we have to solve these equations, find A, B, C, put them in this first equation which we have found, and then get the expression. Easy, right? So we got B already. Now we can find C. C is equal to minus 1 by 2, right? Putting C into this equation, we get A minus 1 by 2 equal to 0. So A is equal to 1 by 2. So we got A, B, C. Put in this equation 1. T is equal to K times L raised to A. A is 1 by 2. M raised to 0. So it's independent. M raised to 0 means 1. So that means it is not dependent on the mass of the bulb. Our assumption in the question was wrong. It's not dependent on the mass of the bulb. The size of the mass of the bulb, even if it's 1 kg, 0.5 gram, any mass, the time period of the oscillation would be the same. And G is raised to minus 1 by 2. Okay. If we write this properly, K root, half is this root. This is minus, so it's on the denominator. G. M is 1, so we don't write that. So T is equal to K into root L by G. So we got this equation. This is what they asked for. We can't find out the K. So that's the drawback of this method. The drawback is we cannot find dimensionless constants in using this method, but it's very useful in deducing relations among interdependent equations. So we understood T is dependent to the root of L by G, but we don't know this dimensionless constant. If we were to write the actual equation found was 2 pi root L by G, which is close enough. Our K was 2 pi. So we found the root L by G, that are variables. We didn't know the dimensionless constant, but this was the answer they were looking for, and this gives you approximately 4 marks. So such questions will come, and to do it you just find out the factors which they have given. Here they gave length of string, mass of bulb, gravitation. We just equate them to variables, write them in dimension form, equate the variables, find the variables, put them back into that equation and find the expression. Very simple. It's a easy 4 mark you can score easily.